this video, we're going to talk about how to find the area and arc length of sectors or arcs using radian measure. We're also going to review how to find those when our angle is in degrees. So the first thing we need to know is what is our formula for the area and arc length of sectors when we're in radians. So here's our note card that we're going to complete. So if you're in one of my classes, you've already completed the degree half of this. So now we still have our same variable. So S still represents arc length, R represents our radius, and theta now represents our angle, our central angle, but it is in radians. So you've got to kind of watch out for that. And then our A still represents our area. And just if you recall, you should have this other side already completed. So let's practice. we're going to practice both of them. So in a circle with radius 4 centimeters, find the arc length subtended by a central angle of 2.4 radians, and then again by 10 degrees. So let's start with the radian one. We know that our arc length formula is S equals R theta. Well, this right here is our theta, and here's our R. So to find our arc length, all we need to do is plug in our values. So we'll have 4.00 times our radian measure, which is 2.40. And then our arc length is a linear measurement. This is not going to be an angle when we're done, so don't put a degree symbol on this. But we end up with 9.6, and it's going to take whatever this value is, or that label. So it'll be centimeters. And then the same thing with our degree. If you recall, our formula for degree is theta over 180 times pi times r. So once again, you can kind of see here's our conversion part of that. So let's go through and do this. So we'd have 10 over 180 times pi times our radius, which is 4.00. And this time we'll have to get kind of an approximated thing because pi, once again, is an irrational number. So if you wanted to leave it in terms of pi, that is totally fine. You'd end up with 2/9 pi and then centimeters. Or you could continue going and actually multiply through the pi, and you'll get a decimal point. So you'd have 0.698 centimeters. So that's finding arc length. So 1 in radians, 1 in degrees. Let's talk about when we've got an area of a sector. So our area of a sector formula, so we've got radians and degrees again. So our area of a formula sector, sorry. It once again, okay, so hold on 1 second here. So our area of a sector is still, it's 1/2 r squared theta, we're in radians. And then when we're in degrees, it is theta over 360 times pi r squared. So you might double check those formulas on your note cards. But once again, this is our theta, this is our r. So we can go ahead and plug things in here. So we'd have 1/2 times 3 squared times our radian measure, which is 0.1332. These are a little bit harder to get exact if you have decimals like that, but you can still definitely just have a lot of decimals in your answer, which is really just fine. So then this first one, we'll just go ahead and do the full decimal. So it'll be 0.5994, and since it's an area, it's our label unit squared. And then over here, we'll set it up. So we'll have area equals 110 over 360 times pi times 3 squared, which happens to be 9. So 110 divided by 360, and I'm going to go ahead and just take that times 9, so I can leave things in terms of pi for now. So we'll have 11 over 4 pi, once again, meters squared, or I can go ahead and go through and tell what that is. So I'd take 11 over 4 times our pi, and we'll get an approximate answer of 8.639 meters squared. And that's finding arc length and area of a sector. no matter if you're in radians or degrees.